Good evening, participants. A warm welcome to you all to the 10th session of our talks on overview on smart substations presented by Ms. Malavika Unnikrishnan of LBS ITW. On behalf of IEEE Kerala chapter, I welcome Malavika to present the talk on overview on smart substations. Malavika, over to you.
Thank you, Madhu. Good evening, everyone. I am Malavika Unnikrishnan, second year computer science student from LBS Institute of Technology for Women at Trivandrum. Today's my topic is an overview on smart substation. So, let me start.
Yes, you
First
can.
slide. Thank you. How do we get electricity at our home? Electricity reaches our home mainly by three phases, that is, generation, distribution, and transmission. The first phase is the power generation. The first step to get electricity is to generate it. The place where electricity is generated is the power station or the generating station. The power station can be of different types, like thermal power station, hydroelectric power station, nuclear power station, solar power station, etc. The main purpose of all this is power station is to generate a huge amount of electricity. In thermal power station, electricity is generated by the combustion of coal or natural gas. In hydroelectric power stations, energy of moving water is converted into electrical energy by means of huge hydraulic turbines coupled with generators. Likewise, in nuclear power station, nuclear reaction causes the generation of electricity, and in solar power station, solar energy is converted to electricity. The power is generated at a standardized voltage of 11 kV. In Kerala, the main power sources are hydroelectric power stations, and there are about 31 hydroelectric power plants in our state. Solar energy, wind energy, and hydroelectric energy. All these sources are known as green sources of electricity as they do not cause any kind of pollution. So, the next step in the path of electricity is the transmission. As the power stations need a huge amount of land, and also since it is located near to the resources, power generator needs to be transmitted to desired location. The voltage at transmission is done at as 110 kV, 220 kV, etc. Did you see the difference in transmission voltage and generator voltage? We have generated voltage at 11 kV, but we are transmitting it in higher voltages. That is, we have stepped up the voltage for transmission. That is because the transmitting power at high voltage reduces many losses, including resistive loss, inductive loss, etc. And also, it helps to save a huge amount of money. Look at this picture. Here, we can see this conducting lines transmitting the electricity, and these are the huge towers which carries this conducting station. One of the main purpose of this tower is to maintain a clearance between the ground and the conductor. Then moving to the last phase in the that is the distribution of electricity. Conductors carries electricity from transmission system to individual consumers by stepping down the voltage to a minimum using transformers at the distributed substation. Common distribution voltages includes ranging from 2 kV to 35 kV. In Kerala, our house receives a power of about 230 volt at a 50 Hz frequency. This layout shows the path of electricity from generating station to the end consumers. This black color indicates the generation, blue color indicates the transmission, and the green color indicates the distribution phases. From the generating substation, the electricity is step up for the easiness of transmission, and it is transmitted to a step down that is transmitted to a distribution substation, and it is stepped down to a lower voltage, and it is delivered to the consumers. The consumers are of mainly three types: secondary consumers, primary customer, and sub-transmission customers. The secondary consumers are that is our home, etc. The primary customers and the sub-transmission customers are mainly the industries, large-scale industries, and the small-scale industries. Now we are going to the next topic, that is the traditional substations and its limitation. Although our country uses the traditional substation, Hello. Hello. Am I audible?
Yes,
Hello, Madhu. Am I audible?
yes, you are.
Okay. So, moving to the traditional substation. A substation is a part of an electrical generation, transmission, and distribution system. Substation stands for voltage from high to low or reverse or perform any several other important functions that which we will discuss in the next slides. Between the generating station and the consumer, electric power may flow through several substations at different voltages. Example of substations include distribution substation, transmission substations, etc. The picture shows Moolamatam Powerhouse located at Idukki district of Kerala as the main power source of our state, and it is the biggest hydroelectric project in India too. The installed capacity of this powerhouse is about 780 megawatt, consisting of six generated units of 130 megawatt each. Although our country uses this traditional substation, it has a lot of limitations. First one is the difficulty to do any maintenance. This substation consisting of huge equipment and its maintenance will be very difficult and sometimes it will be a dangerous too. The next point is the failure of the components results in the shutdown of the entire substation. This point can be explained by using an example. In a three-phase generator, the failure of one of its phase leads to the shutdown of the full generator itself. The next point, the dirt and dust always deposited over the contact switch and other equipment, and thus the maintenance cost can be increased. For example, look at this picture. It shows an aerial view of a switchyard of a substation. From this picture itself, we can imagine how big it will be and how much time we take to clean the. The next point is chance of blackout. Don't you know what is a blackout? A blackout is a total crash of the power grid due to an imbalance between power generation and power consumption. At such times, we would well see electricity demand exceed the supply. In that case, an imbalance is said to exist between the generation and the consumption. This imbalance is also dangerous thing as it would be cause electricity grid to crash, which is a worst case scenario. In India also, a blackout has occurred in 2000. Northern and eastern state of India was dark for 2 days. This outage affected more than 62 crore population of India. The next point, no communication or bidirectional connection. In traditional substation, there is no communication between consumers and substations, which can lead to many problems. So, we have seen the limitations of traditional substations. Does the development of smart substation will be a solution for these limitations? Let us have a look on smart substation. What, why, and how is smart substation? From a viewpoint of a power system, a smart grid is a complex system that enhances energy efficiency in a new powerful environment having communication based system operation. The biggest change in the smart grid environment is the altered operating environment. Considering a smart grid environment that has a variety of characteristics, the implementation of smart grid may pose few problems. It leads to the research into the connection between existing system and the smart grid, that is the substation. This leads to the realization of smart substation automation. A novel substation automation system that considers the operation of a smart grid and involves smart function to make full use of powerful system environment for the most efficient operation of a substation. Uses of sensors, actuators, and automation processing powers are helpful in doing the substation automation. In this picture, we can see a picture. In this picture, we can see a smart grid. The major energy sources are wind, solar, hydroelectric, thermal, and the nuclear energies. The, these two energy sources are called, that is, wind generator and photovoltaic energy are called renewable energy sources, and it will be the future energy sources. Now we are going to the components of a smart substation. The first one is microprocessor based intelligent electronic devices. IEDs are microprocessor-based controllers of a power system equipment such as circuit breaker, transformer, relays, etc. The function of the IED is to sense the anomalies in voltage, current, and frequency and issue control commands. And it also provides the input and output to the system while performing processing services. The next point is transducers, position sensors, and cluster of interposing relays. Transducers are employed at the boundaries of automation, measurement, and control system, where electrical signals are converted to another forms. The use of position sensor is to indicate absolute position or relative position in terms of three-dimensional space, rotation angle, etc. Interposing relays are used to connect the digital signals. The next one is the controller. A controller is used as a mean to connect into a substation automation system. Then, a substation display or a user station. It is a part of a substation host computer and it's also known as a local server. And the last one given is utility operation centers and maintenance offices. Before going to this point, you have to know about SCADA, that is Supervisory Control and Data Acquisition System. SCADA is a control system architecture comprising computers, network data communication, and graphical user interface for high-level supervisory management. How SCADA works? SCADA system gathers information such as where the fault has occurred, transfers the information back to the sender side, alerting the home station that the fault has occurred, carrying out necessary analysis and control. Going back to our point, that is utility operation centers and maintenance offices. Most of the smart automation systems connect to a traditional SCADA system master station, serving real-time needs for operating the utility network from one or more operation centers. Like this, smart substation also incorporate a variation of SCADA remote terminal unit for this purpose, where it is possible to support multiple clients simultaneously. In this picture, we can see certain teams like SCADA, phaser measurement, CRAS, FACS, advanced conductors, etc. We have already discussed about SCADA. The next thing is phaser measurement. As a device used to estimate the magnitude and phase angle of electrical phasor quantities such as voltage, current, etc. Next is centralized remedial action scheme or CRAS. As a practice of to deploy remedial action schemes at substation to protect transmission facilities from overloading under contingency situations. The next is FACS or Flexible AC Transmission System. It is composed of static equipment used for alternating current. Transmission in electrical energy is meant to enhance controllability and increase power transfer capability of network. Generally, if we want to use an electrical energy of one unit at home, the substation should transfer or transmit 2 units of electricity. That is, there will be a loss of 1 unit of energy during the transmission. This type of loss can be reduced by using FACS. The next one is advanced conductors. Currently, we are using aluminum conductors, steel enforced, bare overhead conductors. Recently, a number of advanced conductor technologies have emerged that offer varying degrees of improved efficiency, capacity, reliability, etc. Examples for advanced conductors are invert, gap, etc. Going to next one, that is advanced metering. Here, the current reading or the values of our meter can be seen at the substation at the same time, and also in which explicit requests can be communicated to customers. The next one is the demand response. Here, demand response seeks to adjust the demand for power supply instead of adjusting the supply. Utilities may signal demand requests to their customers in a variety of ways, including simple off-peak metering, in which power is cheaper at certain times of a day. The customer can adjust power demand by postponing some tasks that require large amount of power. And the component include the next one is the distributed resources. These are the electricity producing resources or controllable loads that are connected to a local distribution system. This includes solar panel, combined heat and power plant, etc. These distributed energy resources offer greater customer services. DR enables collection of energy from many sources, and it may lower environmental impacts and improve the security of the supply. Now we are going to the next slide, that is and the environment of a smart substation. For the smooth functioning of a smart substation, we need a good environment, which includes communication network, communication topology, communication protocol, cyber security, IEDs and automation devices. First one, communication network. Both wired and wireless types of communication can be used. If the funding is limited, it's better to use wired types. There are advantages for both wired and wireless types. If I say the advantages of wired, it is very faster, it is reliable, and it is more stable. And about the advantages of wireless, it offers greater independence of connection, it is ease of expansion, and it's easy to maintain. Although both of them have their own advantages, considering the current technology and costs, wired networks presently offer more benefits. Maybe in future the wireless communication may become more beneficial. The next one is communication network topology. I think you all know about different kind of communication topology such as ring, bus, star, and tree. Here in case of smart substation, we are using star topology. Compared to other topologies, star have more advantages like better performance for isolation of devices, benefits from centralization, no disruption of the network when connecting or removing devices. So we suggest star topology. The next one is communication protocol. Although many protocols such as Modbus, DNP30 are related to smart substation, IEC 61850 is the most suitable for smart substation automation because it was designed for the substation automation system. This protocol can run over transmission control protocol or internet protocol network in the substation. The next one is cybersecurity. The basic cybersecurity considerations of smart substation environment are time delay from security process such as encryption and decryption will affect the speed of our operation during flows. Only authorized devices can be permitted access to local network. The security process can affect the transmission time or the reliability of measurement of data. The type of security changes depending upon the importance of information being transmitted. The next was alternating operating plans should be preferred when communication network is down due to cybersecurity. The next point is IEDs and automation devices. Modern sensors and other IEDs are life-giving organs of a digital system. The incorporation of intelligent electronic devices into substation was one of the early adaptations. IEC 61850 standard facilitate the interoperability between different equipment and suppliers that makes it possible for these organs to communicate within a substation. By the use of IEDs, the substation is able to integrate, process, and display parameters such as conditions of the equipment, environmental and weather conditions, thermal camera imaging, cyber and physical intuition of data. Another possible advancement with a digital substation is wide area automation and communication. This WAN interface can be integrated into the grid operator's wide area control system, and this allows the implementation of faster inter-substation control and protection schemes. So, we are going to the smart functions of a smart substation. The first one is the optimized operation. Optimized operation includes PQ control of an equipment, where P is a real power and Q is a reactive power. Real power is the power consumed by a resistor. That is simply if we say power consumed by light in our home. Then Q is a reactive power. That is the power consumed by the inductive and capacitive components of an equipment. For example, fan, motor. In reactive power, there will be a phase difference between voltage and current. This type loads are worked by reactive power. What is the role of what is the role of these power in smart substation? Let me check. There will be a number of consumers under a substation. Sometimes it will be industries. So when they use their machines, it consumes a large amount of reactive power. A substation is not equipped for this voltage level, then the voltage getting from the secondary consumers will decrease. That is, voltage dip occurs. If we have a smart substation, then these sensors in the smart substation sense that company or industry needs a large amount of reactive power, and they will transmit it to the industry. This will decrease the chance of voltage sag. The next one is protection. There are some changes in protection scheme of a smart substation compared to the traditional substation. The first is the change of storing the data, that is from local server to a remote server. This will increase the protection of the data. The second is the change to high-speed communication-based coordination scheme. A fault on a transmission system causes large amount of current flow. By the use of communication-based coordination system, we can sense this easily and we can isolate the components faster. In addition, IEDs also help in protection. One backup IED is able to replace various primary protection IEDs. One protection IED receives data regarding to a protection target of the IED through calculation and communicates itself when a measurement device stop functions. The next smart function is the restoration. Faults in inner substation may due to bus bar or the main transformer. A bus bar is a metallic strip or a bar used for local high current distribution. A bus fault can be restored by switch control, and the restoration of main transformer fault calls for distribution of the load of the transformer that experienced the fault. The next one is distributed control based operation. For the smart substation to be independent and more efficient, distributed control based operation may be realized. This type of operation will help to reduce the burden of the server and increase the efficiency of substation functions. In the scheme, what happens is that the server assigns a function to the terminal device, which then accomplishes that function, making their own decisions. Once the function is accomplished, the terminal device leader reports it to the server. Moving to the picture, we can see the difference between the path of the electricity before and after the smart grid. Before smart grid, there was only one-way communication, that is generation, transmission, and distribution. The electricity is generated at the power station, it is transmitted via conductors, and it reaches our home. But after smart grid, it changes. The communication becomes bi-directional. That is, the consumers also can communicate with the power station. And also, there came a bidirectional flow of electricity. We can transfer the extra energy generated at our home to the power station by the use of controlling sensors. These sensors can measure the amount of incoming and outgoing power, and thus it helps in bidirectional communication. The next slide is a video about smart substation. Let's go through it. So, we have seen. Hello, am I audible? Hello, Madhu.
Yes, you are.
Okay. So, we have seen a video on smart substation by Schneider Electronics. There we have seen some things about IoT, isn't it? What's the role of IoT on smart substation? We will discuss. The IoT concepts allow objects to share data through wired or wireless communications for communication purposes. As the operation of the power system is extremely time critical, low latency communications need to be considered for most control and monitoring applications. Therefore, system operators can use real-time monitoring system to provide better decision. The IoT platform provides remote visualization for system operators in real time. With the help of IoT, we can monitor various parameters like voltage, frequency, circuit breaker status, temperature in substation, etc. We can store information on a database and we can develop IoT security too. By using IoT, we can automatically control the load shedding by considering the demand of power. Along with this, I would like to discuss about wave traps or line traps. Now, this technology allows substations to communicate each other along with the transmission of power. In order to separate power from messages being sent, different frequencies can be used. Why I'm telling this here is that it's an emerging technology. We can use it for communication among the consumers and we can fix a broadband for that. This is not currently available, but in future we can expect. Moving to the next slide, that is the advantages of smart substation. First one, digital intelligence gives substation operators remote control of facilities. That is, the use of IED and IoT enable the operator to control equipment in an easy way. The second point, allow faster adjustment to condition. The components of smart substation are easily adjustable to various conditions compared to traditional substations. The next one prevents blackout, make faster for recovery. It prevents blackout up to a level. If the demand for electricity increases, it can be sensed by the sensors present in the smart substation and thus it prevents the total power crash. Next point is more flexibility to reroute power. If you consider a situation where you face an outage of power in your house, and if you are enabled with smart grid or smart substation system, then the power can be rerouted or substituted from another electrical post to your house rather than the post already been faulted. The control of the power flow through all those smart posts and smart grid is controlled by smart substation so that with the slight changes in the control system and substation part you can control the direction of electricity flowing from one place to another. The next point is support the power system real-time control. The use of IoT in smart substation enable the real-time monitoring. That is, we can monitor the value of voltage, current, etc. And we can also understand about the temperature difference, circuit breaker status, etc. The next point is improved customer access to information and also improved information for energy engineering decisions. There is the use of smart grid and the smart substation provide better customer service. The smart meters reflect the real consumption of each month bill instead of estimates and reducing the cost of all the system of manual energy meter reading. On the engineer side, a fault occurred can be easily detected and it can be rectified easily. Although it has many advantages, it has some disadvantages too. The first one is initial cost of the system. Initial cost will be high for the development of a smart substation. The next one is requires skilled professionals to operate the system. A common man cannot operate the system as it uses many type of technologies like IoT. It requires a skilled professionals. The next one, as the system uses some open protocol, the security also matters. Power station security really matters because the remotely accessible devices used within the substation are largely unprotected against intrusions. The messages that IEDs exchange with the outside world are often transmitted over communication channels that are open to active intrusions. The next one is the lack of standards. Digital substations with the IEC 61850 standard are widely deployed in the world. However, for the implementation of intelligent functionalities, there lack standards and specifications for system architecture and network configuration. And the last point is high voltage equipment replacement. Replacement of high voltage equipment such as transformers, switchgear, etc. is very difficult. So replacement occurs very rarely during the conditions like aging of transformers, inefficient working of equipments, etc. Now, we are going to the future scope of smart substation. First one, urban and rural development. Smart substation will lead to the development of urban and rural areas. It will affect mainly the urban areas. The next one is leading companies and upcoming innovation. Leading companies in this technology are Siemens, ABB, General Electronic, etc. China is integrating next generation smart technology according to State Grid Corporation of China. The project uses the ACT software, state of art software, and power technology to enable remote control, protection, automation, monitoring, and diagnostics for the substation, as well as to allow a reduction in their operation cost. The next point is job opportunities in the field of fax, IoT, standards, and power electronics. Job opportunities will increase in the field in technology. Thus, the technology is developing and skilled persons can acquire the job easily. Next slide is I will show a video which shows the future scope of digital substations developed by Siemens. So, we have seen a future distribution substation with integrated IoT connectivity. We have seen that we are coming with a project optimized for environmental protection and space saving modular components for an efficient grid. In future, our country can also expect the smart substation automation system. Now, I'm moving to the statistics of a smart grid technology. We can see a huge development in the smart grid technology. The first graph shows the number of smart meters employed in the United States annually from 2007 to 2018. As of December 2008, it becomes 90 million of smart meter units had been installed. The second statistics shows the smart grid technology revenue in the world from 2012 to 2020. This graph also showing the huge development in the smart grid technology. So the session is coming to an end. Let me conclude. I hope this presentation has given you an overview on smart substation, its advantages and limitations. The operation practice has proved that smart substation is more flexible and adaptable to changing environment. Hence, it is more suitable for modern smart grid with increased utilization of renewable energy. As the practical issues are solved, the smart station concept will play a more important role in future substation design and its construction. I hope you understood this section and it was clear. My name is Malavika Unnikrishnan. You can connect me by my email ID or my contact number. Thank you. Is
Thank you,
there any
Malavika.
doubts? Hello? Is there any doubts?
If you have any doubts, you can just put it in the chat box. We have just less than a couple of minutes. So thank you, Malavika, for the presentation. On behalf of IEEE Kerala chapter, I would like to convey our gratitude for presenting your talk on overview on smart substation. I hope it was an informative one. Also, I would like to thank all the participants for registering and participating in this session. Thank you all.
So, thank